Now, yesterday I discussed about the power and number of units consumed in the house and also the power bill. I have given that power is equals to power P is equals to work by time and also energy by time. But we know that potential V is equals to W by Q, we know in the first chapter. Therefore, W is equals to VQ. Therefore, power is equals to VQ by P. But what is Q by T? But again, Q by T is equals to charge by time. That gives current I. Therefore, power is equals to this Q by T is equals to I. Therefore, power is equals to V into I. V into I is expression for power. Also, as V is equals to IR, therefore P is equals to IR into I, implies P is equals to I square R. This is another way of expressing power. Also, as again V is equals to IR, therefore I is equals to V by R. Therefore, from this equation, P is equals to, in place of I, we place V by R, that is equals to V square by R. Therefore, power formats are power is equals to voltage into current, that also equals to I square R, that is equals to V square by R. These are different ways of expressing power in terms of voltage current, current resistance and voltage resistance. So, this is the extension of power. Now, in series combination, what remains constant? Written I is equals to constant. In series, current is equals to constant. Therefore, P is equals to I square R, implies P proportional to R. I is constant. Therefore, in series combination, P proportional to R. In parallel combination, so what remains constant? V is equals to constant. Therefore, P is equals to V square by R, implies P proportional to 1 by R. From this equation, P 1 by R, P proportional to R. This is series, this is parallel combination. This is something at the extension of power. Now let us see what is a cell. Cell and combination of cells and maximum power transfer theorem. Now what is a cell? Come with this word cell. A cell is nothing but a device that maintains a constant voltage, or you can say constant potential difference between any two terminals. The device that maintains a constant potential or potential difference between any two terminals in the circuits, which converts the chemical energy into electrical energy. Is called as a electrical cell. Now, what is EMF? Electromotive force is called as EMF. Electromotive force is called as EMF, the force which motivates the electrons. The force which motivates the electrons is called as the electromotive force, or is the ability to drive the charges. We can also say it as ability to drive the charges. In the circuit is called as electromotive force. It is also called as potential. The unit is potential. That is, we can say it as potential also. Unit is volt. Unit is volt. Now we know that V is equals to W by Q. If Q is equals to 1 unit, then V is equals to W. Then we can define the EMF as the amount of work done in moving the unit positive charge in moving the, like that, you can say it as a charge in moving the unit positive charge in the circuit through the cell itself also, through the including the cell also. It is the work done in moving the charge, unit charge, through the cell and also through the circuit. It's also called as electromotive force. They are all different definitions. The force which motivates the electrons, which drives the ability to drive the charges, work done in moving the charge. These are all different ways of expressing the electromotive force, whose unit is simply volt. Now the representation is, the general representation is, cell representation is something like this. So this is the representation of a cell. This is EMF E. This is positive, this is negative. This is positive and this is negative. Now what is internal resistance? So in general, this is a cell. Some electrolyte will be there. This is positive and negative. Some electrolyte will be there. So due to the flow of these charges, some resistance will be there between the two electrolytes, between the two electrodes. The resistance between the two electrodes is all represented by smaller. The representation of internal resistance is smaller. The resistance between the two electrodes is called the internal resistance. The resistance between the two electrodes is called as the internal resistance. It depends on area, distance between the plates, strength of the electrolyte. All this area, distance between the plates, strength of the electrolyte, is all. It depends on this various factor. There is an internal resistance. For ideal cell, R is equal to 0. For ideal cell, R is equals to 0, but that is not a possible case. So R will be very as small as possible, 1 ohm or 0.5 ohms or 1.5 ohm, like that. It will be very small. Therefore, the resistance between the two electrolytes is called as internal resistance. Therefore, generally representation is, this is cell now. So this is internal resistance R. This is EMF E. Internal resistance R and EMF E. Generally, in many cases, we neglect this one. We write this one as E and R. If we give like this E and R, then it indicates that the internal resistance is R. Cell is having EMF E volts. So in some cases we can write like this and also represent like this. ER separately or simply E and R. It indicates that it has some internal resistance. It will be given some 10 and 1. So 10 is the 10 volts and 1 ohm resistance. EMF is 10 volts and 1 ohm is the resistance, internal resistance R. This is representation. Now, so what is the terminal potential and last voltage? So terminal potential means, so this is the cell, this is the internal resistance R, and this is the external load resistance R. This is capital R. This is small resistance. This is electromotive EMF E. We can also take it as this one, like this one also. Simply like this one. This is R. This is E and R. This is R and this is E and R. Now what happens here? See, this is the resistance R. The resistance between the two terminals. The terminal potential is the potential across the external resistance. The potential across the external resistance or the potential between the two terminals. The potential between the two terminals is called as the terminal potential, or you can say it is the resistance. This is the potential across the external resistance. The potential across the external resistance is called as terminal potential. V is equals to IR. Okay, therefore V is equals to IR. The if the current I is flowing like this, then what is the potential across the resistance? V is equals to IR. So this is what is called as the terminal potential or terminal voltage. Now what is last voltage? Last voltage. This is, see, as the cell is also having some some internal resistance R. So it also draws some potential. The resistance also draws, there will be some potential across the resistance also. Which resistance? This, just like this one, there is some potential is taken from this potential across through this resistor. Therefore, here, this is the resistance R. This is the cell. Now, the potential is, the current I is flowing like this. Then, what is the potential across the resistance? I into small r. This is the last voltage. Therefore, terminal, this is the terminal voltage. This is terminal voltage. This is the last voltage. Therefore, the applied EMF is split into two parts. One is the terminal potential, another one is the last potential. Terminal potential and last potential. The last potential is nothing but the voltage across the internal resistance. The voltage across the internal resistance is called as last potential, and the potential across the external resistance is called as terminal potential or terminal voltage. Now what is the E? E is equals to, what is E? E is equals to, so terminal potential, V terminal potential plus V last. This is V last. Let us take it as this is VT terminal potential. Then total EMF E is equals to V terminal. So if it is 10 volts, some 1 volt will be there here, some 9 volts will be there. So 1 volt will be across the internal resistance. So 9 volts will be across the external resistance R. After 10 volts of EMF E. If E is equals to 10, the IR is equals to some 1 and VR is equal to some 9. Therefore, E is equals to terminal voltage, that is voltage across the resistance, plus last voltage, voltage across the internal resistance. Therefore, E is equals to, terminal voltage is IR plus VL, last voltage is IR. Last voltage is IR. Then what is E? E is equals to I into R plus R. This implies the current I is equals to E by R plus R. Current I is equals to E by R plus R. E by R plus R is the current I. Now, V is equals to, therefore we got E is equals to IR plus IR. From this equation, I is equals to E by R plus R. Keep it aside. The current in the circuit is, this is R, this is ER. If we take like this, this is positive, negative, this is R. Therefore, the current I is equals to, E by R plus R. Now, we can call this VIR as V, the terminal potential. Therefore, E is equals to V plus IR. E is equals to V plus IR. This implies V is equals to E minus IR. V is equals to E minus IR. V is equals to E minus IR. This is very important one, and this is very important one. Here, this is something like some 6 is equals to 10 minus 4. 6 is equals to 10 minus 4 format, isn't or not? Which one is greater? Therefore, E is greater than V, or we can say V is less than E. V is always less than E. V is less than E. Okay. Now, what expression for internal resistance? You may come across this in a many number of problems. Expression for internal resistance. Now, from this equation, IR is equals to E minus V. Therefore, R is equals to E minus V by I. R is equals to E minus V by I. But again we have, as V is equals to IR, I is equals to V by R. Therefore, R is equals to E minus V by R. R is equals to E minus V by R. This implies this equals to E minus V into R by V. This implies R is equals to R into E by V minus 1. R is equals to Internal resistance R is equals to R into E by V minus 1. R into E by V minus 1. Okay, this is something about the internal resistance R. Okay, internal resistance R. Now let us see next one. Okay, internal resistance R is equals to R into E by V minus. This is the important one in doing the problems. How to calculate internal resistance when you are given terminal potential and EMF of the cell and external resistance R. Now let us see the directions now. So V is equal to E minus IR. This is valid when this is like this. This is R, this is minus, this is plus, this is E. Then V is equals to E minus IR. This is a potential across the external resistance. R is the potential between the two terminals. This is the potential between the two terminals. Is called as the terminal potential. V is equals to E minus IR. We can call this one as discharging case. We call this one as discharging case. We call this one as discharging case. Now, if it is like this, this is external resistance R and this is negative, this is positive. The current is flowing like this. Current is flowing like this. Then this is V is equal to E minus R. The current direction is reversed. If it is flowing from negative to positive, then it is V is equal to E minus IR. If it is flowing from positive to negative, anode to cathode, then this becomes V is equals to E plus IR. In this case, here definitely V is less than E. V is less than E. Here V is greater than E. This V is greater than E. The current is flowing in the otherwise direction. So this is, you remember this one very importantly. And if the current direction is reversed, you take this one as the V is equal to E plus IR. We can call this one as charging case. We call this one as charging case. This is discharging case. This is charging case. So directions are very important one. So V is equals to E minus IR. V is equal to E plus IR. When we take E minus IR, then it is flowing from cathode to anode. When flowing from cathode to anode, inside the cathode to anode, inside the battery, this is called as discharging case, and V is equals to E minus IR. Now, let us see small extension to this one. V is equals to, what is open circuit and what is a short circuit. Okay. Now we know that V is equals to E minus IR and V is equals to IR also we know. From this also equation I is equals to E by R plus R. The circuit is something say like this. The circuit is like this. Let us say the circuit is like this. And now circuit is like this and current is flowing from like this. Current is flowing like this. This is external resistance R, this is R, this is R, this is E. Then we say that here if R is equals to infinity, if R is equals to infinity, then what happens? If R is equal to infinity, then what is the current I? I is equals to E by R plus infinity. This becomes E by infinity is equal to 0. Current I is equal to 0. When current I is equal to 0, we can call it as open circuit. We call it as open circuit. When current I is equal to 0, we can call it as open circuit. When circuit becomes, this is written as, this can be written as, this is R is equals to infinity, this is small r, this is E. Circuit is, the circuit is open circuit. This is open circuit. Open circuit. Now, if R is equal to 0, then what happens? If R is equals to 0, then what happens? Then I is equals to E by 0 plus R. This implies I is equals to E by R. Implies E is equals to small I into small r. Then what is V? V is equals to E minus IR. This implies V is equals to E. E means IR. IR minus IR. That is equal to 0. Then V is equals to 0. Then therefore V is equal to 0. Then we call circuit as short circuit. Short circuit. We can call it as a short circuit, and current is equals to, when R is equal to 0 implies current is equals to infinity. Current is taken as very high value. Therefore, in this case, circuit can be written as like this. Actually, we can take R is equal to 0, no? R is equal to 0. Therefore, there is no need of taking this one, and this will be E. This is R. This is short circuit. Short means join the two terminals. Short means joining of two terminals, and open means just open the circuit. Then break the circuit. If you break the circuit, that is called as open circuit, and remaining, if you join the terminal, is called as short circuit. This is something about open circuit and short circuits. Now, if you take two cells like this, this is E1, R1, this is E2, R2, accelerations are, the current I is flowing like this. Two cells, if you take two cells, E1, R1 and E2, R2, and accelerations is R, then what is the terminal potential across the first cell? V1 is equals to, V is equals to E minus IR, no? V is equal to E minus IR. Therefore, V1 is equals to E1 minus IR1. V2 is equals to E2 minus IR2. V2 is equals to, this terminal potential is V1 is equals to E1 minus IR1. And here the terminal potential is V2 minus IR2. Is the terminal potential. Now, what is the E equivalent? E equivalent is equals to E1 plus, therefore V equivalent is equals to V1 plus V2, E1 plus E2 minus I into R1 plus R2. V is equals to E1 plus E2 minus of I into R1 plus, this is what is called as E equivalent. This is R equivalent. Now, what is the total current now? Current I is equals to E equivalent by R equivalent, plus we are having accelerations R also. In circuit we are having accelerations R also. This implies I is equals to E1 plus E2 by R1 plus R2 plus R. The current in this case, cells are there, number of cells are there here. Then I is equal to E1 plus E2 by R1 plus R2 plus R. You see, the direction of one is reversed. The cell is like this. The cell is E2 R2. This is E1 R1. If one of the cell direction is reversed, then what happens? Then I becomes E1 difference E2 by R1 plus R2 plus R. The current I is equals to E1 difference or E1 minus, you can take it as E1 minus E2 by R1 plus R2 plus R. Number of cells are given, if the direction of one cell is reversed, then E1 minus E2 by R1 plus R2 plus R is the, if the combination of cells are given, this is the methodology. Now let us see for the maximum power transfer theorem. We will discuss that in the next class 11. And series cells in series combination and cells in the parallel combination, different number of cells, all we see in the next class 11. Okay, thank you.